reminding you, there's a test on this, in this class on December 8th.
December 7th.
7th for you guys. Thank you. Hold on.
We picked the
Ticket. Ticket. Move up.
Usually, you know, sometimes he like goes out full class tickets.
Well,
I actually do it. I just do it in a different way.
Okay.
He says to for everyone.
He forces. Like I actually do it a lot.
Yeah, I just realized that.
Yeah, don't worry. I just don't use
I
his.
know it was slow.
Yeah, he got it from me to go. Okay. Just saying.
Why did you keep the show last night?
Yeah, I did. Do you come to show?
No.
I'm trying, but it's hard. There's this thing that's going on.
It was
I
really
spend so
good.
much time here trying to help people.
I think
Treating family matters or something. Well, you know. Hey, here's 26. You know, in college, you can miss all the class you want. They don't care.
you pay for it.
Well, yeah. You already paid. You paid before you start.
Did it take attendance?
No.
Oh,
Oh my gosh, we're gonna miss every day.
I'm just kidding.
Snowboard every winter.
Yes, good idea, Derek.
I've never been so nervous. Is to start. You're already like, you start. There's certain classes that say, I'll start with like Harvard. Most people don't change their habits every often. So if you're working right now, you're like, okay. What if you don't like that?
I was just with her. She's like,
Man.
This is the blue one, right? No.
This is the blue packet.
Somebody probably about 5 years, which is great.
Nice recovery. From where to where?
oh, he's the fourth one.
So from 3 to 4? Is that what you're saying? So I factor. So I see an expression made up of 3 factors. And so,
Hey, I just got an email from next agenda.
all right. I'll say hi in return.
Hey, when are you
You come back right now. Yeah, I'll start back again, just in case we missed something.
Okay.
Why not? More exciting that way. Let's have a question on 26. Please, go ahead.
So on the first line, so the derivative of the second part, the second term, no, sorry, the first one, there's derivative.
So which number?
D,
One?
on the line one,
Line 1.
so there's the d x minus 1 over dx, that one. So isn't the dx over dx is 1 minus 1, isn't that 0?
The mistake you're making is this, but you're close. So this will become dx over dx, subtract d1 over
1
dx,
minus 0.
which becomes 1 minus 0, which is 1.
Oh,
Same question.
Yeah.
Good. Just put Braden back on the back row and you two can sit up here now. It's more fun.
Aw, that was really I agree.
Brayden can hear everything.
Braden can hear
Ears
everything.
around the school.
Well, it is being recorded, so he can.
Hi, Brayden.
They're gonna watch it too.
You don't.
No, it doesn't get any of the, there's no video, it just records whatever happens on the screen, and then you pick up the audio.
So all the cops might be saying all year, like friends, I'll be on the screen.
Yes.
Do you listen to it?
I've never taken that, I don't have to.
I tried joining it.
I would go to Susan and watch my own videos. That's an easy choice.
But I'm gonna email you.
Yeah.
Oh, there you go.
Yeah, like Susan will.
How do you know where his wife's from?
I don't know. She works today at the hospital. My dad basically runs that way.
What's his job?
So he's a family doctor, and then he's like,
Oh, that's cool. Somebody in a family duck. I'm looking, yeah. Hey. Everybody good here? Oh, keep waiting. Don't worry.
She loves it. Because my dad told her that she had to get a $5,000 massage chair for her husband. She was getting massages every night.
I'm good.
Everybody else here? Let's have a different question you brought with you to class. From the home. Cool.
You need to explain how to do the homework.
What's that?
Kidding.
Any comments from the back?
So, can you just give me the,
Which one?
the answer to the meaning of life?
Meaning of life?
In calculus, in terms of derivatives. So you have to study derivatives.
You must find the derivative for eternity.
I can give you this comment. In my experience, the reason why it is important to, why does calculus have meaning beyond somebody who wants to be an engineer where you're actually going to use the calculus? And, well, it's an easy question. Why do so many college majors nowadays require their students to take calculus? It's not because they want you to learn the calculus.
They want you to learn problem solving.
Yeah, they want you to learn how to think logically. Like, many people do not know how to think logically. They don't know how to say, if this is true, then the second thing is true. They're like, a what? Okay? I mean, really, one of the really hot profession right now is patent attorney. Hot profession.
Probably.
Really hot profession now. Really hot profession is patent attorney. And to become a patent attorney, you have to have an engineering degree first, and then you get a law degree, so that you are qualified to step. There's a lot of school. You do get paid a lot once you get through the school. Anyway, moving on. 12. Okay, 12 asks this question. Look up. No one talks. So 12 says you have this function. We're supposed to figure out when the function is concave down. So look over here at Danica's chart. Look. Y will be concave down when the sign of y double prime is negative. So right away I know I need a sign chart of y double prime. So I took two derivatives. That went pretty fast. I factored out at 12. Now the next step in factoring is not hard, but you may have forgotten how to do it. I need to factor this term here. So you start by simply saying what multiplies to make 3x squared. Now that's a 3x and an x. So we have a question there. So, go ahead.
If you're doing the y prime,
So I said we bring down the 4. 4 times 3 is 12. Change the exponent by 1. Bring down the 3. 3 times 16 is 48. Change the exponent by 1. 2 times 24 is 48.
okay.
40. Anybody else?
And then do you just add 48 down below, because that's plus 48 on the...
Right here? No. So this is y prime. Now I'm going to find the derivative. So the derivative of 48x is 48. Makes sense to you?
Yeah.
Good. So far? Look down here on the factoring again. When I factor it, and I would advise you to do the same, I don't pay attention to the signs. Just leave those out for a minute. Just don't pay attention to the signs. These two multiply to give me the 3x squared. These two multiply to give me the 6x. Here's the 2x, and there's the 4. So I don't have any question to that point. So now I go back and say that we've got to make all the signs work. So the only way for a 6x and a 2x to add to produce a negative 8x is if both of them are negative values. So So I say that means this must be negative, this must be negative. Of course, this must be positive. Wow. So look back at how it was multiplied. Well, where did the 6x come from? It comes from these two being multiplied. This one is already positive. Therefore, the only way this can become a negative 6x is if this is negative. Wow, we have a question there. What? Cool. So then we go and say, let's see. This one comes from these, so that means this must be negative. And now it all works, because a negative 2 multiplied by negative 2 is a positive 4. Follow-up questions from anyone? Cool. So, next thing, I need a sign chart. So here are the three factors that become the sign chart. Here they are listed. This factor is a little unusual, so look at what I did here. I said, first step in making a row of a sign chart is to figure out what is the x value which causes this to equal 0. So I just did a little work up here. So 3x minus 2 must equal 0, and I solved for x. That's why I knew this was a 2/3 here on the sign chart. So we want additional explanation there. What you're really learning to do, like I was saying in the chat a second ago, what you should be learning to do in this class is learning to think as you take notes. You're going to need that in college, I guarantee it. I got an email from a student who was taking a psychology class at Utah State, psychology, which you would kind of tend to think, well, that won't be very difficult. She said really much of the class was really struggling, and she wasn't, because she had learned in calculus to think, reason, make sense of things as she's kind of taking notes. She'd already developed that habit, so she wasn't having a hard time. The rest of the class couldn't figure out what the professor was talking about half the time, because they're just too used to memorizing. They're also too used to a pace that is too slow. In many high school classes go so slow that it's like it's really easy to keep up with what's going on. In college, they're not going to wait for you. They have a certain amount of material they want to make sure you understand. They only have 50 minutes to give it to you. You sit down, the bell rings, they start talking. So, do you have a question about this? Okay. Oh yeah, please.
Are they actually going to one prime?
Almost. So this one here?
Yeah.
No worries. So the 12 is always positive. That's an easy factor. This one's equal to 0. Now, everyone look at the board. Everybody look at the board. Okay, one of the most valuable things I can show you about a sign chart is what I'm about to say. Once I know that x is equal to 2/3 causes this factor to equal 0, I only need to do one simple test, actually two simple tests, to fill out the rest of the sign chart. I look to the left. I pick a value of x to the left. Well, the easiest one to pick is 0. 3 times 0 is 0. 0 minus 2 is a negative value. So that means all of these are negative. I do not need to check any other values. Question? Just do this. Oh, please. Jacob.
When it's left of the 0, isn't it always a negative?
I would depend totally on what this is.
Okay.
You could have factors that wouldn't be negative over here. In this case, it is, but it doesn't have to be. I check one to the right. 2 works good. 3 times 2 is 6. 6 minus 2 is 4. Therefore, all of these are positive. Do something similar here. And then to create the y double prime chart, I say, okay, how is y double prime created? It's these three factors multiplied together. So when x is way over here at, say, negative whatever, this factor is positive, this one's negative, this one's negative. So positive, actually easier to go this way. Negative times negative is positive, times positive is positive. Over here, 0 times these two things will be 0, same thing. So now I have the chart for y double prime. Therefore, the answer is right there. Follow-up questions. Emails bring a specific question to class. Okay, so look at your blue packet. Don't do the problem in the packet, but we're going to do problem number 2. Do it in your notebook. The test on December 7th will have at least 2 problems that involve the natural log function. And you've got to be prepared to deal with that properly. So we'll practice that right now. Problem number 2. And this class actually compliments to you. This class is very good at asking questions. No, it's well deserved. You're just very good at it. And in my opinion, you have to have that kind of environment. Like if you have a class where there's enough people who ask questions, it's a really good class. If no one will ever ask anything, the learning is really not as significant. It's much better when you're asking to make sure it's making sense. So keep up the habit. So here's problem number 2. The problem says, at what value does V attain its maximum value? Here's how I figure out what to do. Quadratic chart as always. So I draw V of t, V prime, V double prime. Would be a good time to remember that V prime is the same thing as acceleration. V double prime, we don't have a name for that in our class, we won't worry about it. So we have increase, decrease, hey, stop right there. If I want to see where V is greatest, I need to find out when does V go up, when does V go down. And I can find out when V is greatest. So I don't have a graph to look at, so I have to do sign chart. That tells me I need a sign chart of V prime. Is there any questions to how I figured out from the problem that I need a sign chart of V prime? So we need to say it again, say it differently. Just want to talk about it for a minute.
Say it again.
So it helps if I ask you a few questions, Amanda. We're trying to find out where V is greatest, right? We don't have a graph of V. But let's pretend we did. So I'm just going to put V of t like this. The V graph's going to do something. It's going to go, maybe it goes up, maybe it goes back down, maybe it goes back up again. I really don't know. However, if I can figure out how V basically looks, I will pretty much be able to look at the V graph and say, oh, this is the highest point on V. So this would be where V has its max. Well, without a graph, the only way to figure out when V goes up and down is by studying the signs of V prime. It's a sign chart of V prime. Does that help? Good question. Please, Brayden.
So the max would be the greatest, or like the highest value on V prime?
No, it will not be the highest value on V prime at all. Because we're not trying to find, like, check the problem here. We're not trying to find where V prime has a maximum.
No, like, so like on V prime. Oh, wait, okay, never mind. That's
Okay.
good.
Anybody else, Chad?
Just wondering, like, on the V prime graph, we're going to be looking for local, like, maximums and stuff.
We won't be looking for local max on V prime at all.
Or I mean, sorry, like,
You're
on
okay.
V prime, it's when it flips from, trying to think, a positive to negative. So
Yes, we
like
will be
that.
interested in that.
So yeah, that's right.
Yeah, that's much better. We are very interested in knowing when V prime changes from positive to negative, for sure. Because that will tell us when V changes increase to decrease. Anybody else? Go for it.
So the next step is just find the derivative of V.
Perfect, so we just need to go find the derivative of V. Everybody good? And I erased this picture here. It's not really what V looks like, so I don't want to keep it on the board here. Okay, so I come over here, start working on derivatives. Let's see, so V of t is equal to the natural log of t divided by t. I told you more than once that whenever we differentiate in this class, we always differentiate with respect to the input variable. The input variable for this problem is t. So there's no dx's, just dt's. Now, any anything they need me to clarify so far? So use the quotient rule. A simpler way to write dv dt is to just write b prime. Please, Jeff.
So why is there a t in front of the root right there?
I messed up one thing. Fix your notes for sure. So the quotient rule says you take the bottom, multiply by the derivative of the top, minus the top. That's where it's for. Okay, okay. No worries. Anybody else? The natural log rule says that's going to become, so you got t multiplied by 1 over t, and that derivative of t. That's the natural log rule. This will just be ln of t, and it's all over t squared. That should catch up in your notes. The way the world is going, based on, I try to keep up with current events pretty heavily. The way the world is going, in my opinion, you're going to want to develop a brain that can think as flexibly, as logically, as creatively as possible. Because jobs are just, they're morphing very quickly from one thing to the next. And you've got to be able to show an employer that you can think better, faster, quicker, and more logically than other people. And that doesn't just happen without work. That, to me, is why calculus has value. Because you're changing your brain. Like by going through this process, your brain is changing. It's becoming more logical, it's becoming stronger. By doing this, you have to do something to make it better. So, very good to hear. Cool. So next line is going to look like this. Let's see. This is just 1. So now we have a nice compact equation of b prime. I have a question about that. Okay, the next thing we do is we need to make a sign chart of b prime. We already talked about that. If you look at the numerator can't be factored really easily anymore. So we just have to consider this as the only factor of the numerator, 1 minus ln of t. So the sign chart's going to look like so. A couple of memorized facts. Please write this down somewhere. The natural log of 0 is undefined. The natural log of any negative number, that's also undefined. Those facts need to be in your rapid recall memory. Because if you look back here, they said we're only interested in time that is greater than 0. That's because the natural log of 0 or less is undefined, so there's no way to deal with any values of t that would be less than 0. So our sign chart is a little different than before. It does not have 0 in the middle, it has 0 on the left. And then different values of t to the right. Question, please.
Even if it wasn't like a natural log, if they said, looking at t when it's greater than 0, would you still just put the 0 in?
3 tickets, outstanding question, outstanding. If they say only worry about t greater than 0, you just always worry about just t greater than 0. Absolutely. Regardless of what the function is. It's perfect. Anybody else? All right. It's a little tricky. 1 minus ln of t. How do we deal with that? Let's see here. 1 minus ln of t. And also t squared. Okay, we've got to figure out the value of t which causes this to equal 0. That's where you start a sign chart. So if you're not sure, just write it down. 1 minus ln of t is supposed to equal 0. So let's do some solving. Let's move this over here. Okay, 1 minus ln of t equaling 0 is equivalent to ln of t equaling 1. So we have a question about that. Okay, now you've got to have in memory, in rapid recall, please check.
Why is it supposed to equal 0?
That's how we always start the sign chart. We say somewhere along here, there's some t value which will cause this to equal 0. Once we find that, finding the rest of the positives and negatives is much, much faster. So that's just where we start. So in your rapid recall memory, you've got to look at this and say, okay, wait a minute. I know how to find the natural log of some things. So the natural log of something equals 1. I just got to remember the something. I hear a voice. Natural log of what is equal to 1? This has to be memorized. There you go. E. Oh, yeah. Since natural log of e is equal to 1. We made a flashcard of that just the other day. We said that the natural log of e to any power is just the power. And then we did a bunch of examples, like the natural log of e squared is 2. The natural log of e to the 1, more commonly thought of as the natural log of just e, that's equal to 1. The natural log of e to the 0, more commonly thought of as the natural log of 1, that's equal to 0. The natural log of 1 over e, same thing as the natural log of e to the negative 1, that's negative 1. This has to be in rapid recall memory. It can't be very deep. It's got to be just come to mind quickly and easily, just like multiplication tables. Questions? Cool. So we figured out. Oh yeah, no worries. No hurry. So back here is what I was saying to Chad. So now I know that I can put a point on this number line at t equals e, which is about 2.7. So approximately. And I know that at that value of t, natural log of e is 1. 1 subtract 1 is 0. Question? Okay, look at the board, please. I don't want to see your eyes again. Look at the board. Look up there. When he falls asleep, he's really out. Oh, you can watch the video. Okay. So, there. He likes to wake up. He's been very conscientious lately. There we go. Now I was going to let you sleep, but you've been very good about trying to stay awake. Okay, look. To find what's going on over here, hey, listen. Find what's going on here. You don't have to think logically. You don't have to plug in a lot of points. You have to plug in one point. Just one value here, just some value of t that is less than e, which means some value of t that is less than 2.7. 0 is often a good choice. The only problem is, just say it out loud for me, please. What is the natural log of 0? Undefined, so that doesn't help. So we need another value that we can find the natural log of. 2 works, except for one problem. So you'll see in a second. What is the decimal equivalent of the natural log of 2? And if you're thinking I don't know, you're correct. I don't know either. So that doesn't help very much. Please.
Would it be like what we learned on the boost unit? How it's like the 0 plus?
No, that's not going to help us here. But good idea.
Ln of 1?
ln of 1 is a really good idea. Because Oakley, what is the ln of 1? 0. That's an ln that I know. So I'm going to put over here a number 1, and Oakley's going to help me. So you said the natural log of 1 is?
0.
Good. So 1 subtract 0 is?
1.
And all we care about is the positive or negative, so it is positive. Therefore, all of these are positive. That's why we find the 0 first, Chad, so we can just fill out the rest of it quickly. Anybody else? Awesome. So then we go over here, we just test again. So we need some number greater than e that we can easily plug in and find the natural log of that number. For a hand. Chad.
Like on the thing you wrote the natural log of e to a is equal to a, so could you put anything exponent?
Nice, just pick one. Like e to what?
3.
Perfect. So e cubed, I don't know, my scale is never perfect, I don't really worry about it. E cubed, let's see, help me Chad, what's 3 cubed? 27. So Braden, 2.7 cubed, probably about, I don't know, 24 or something, I'm just guessing. But it's certainly bigger than 2.7. So Braden, what is the natural log of e cubed? No, somebody help us. What's the natural log of e cubed, Sarah? No, that's what e cubed is.
Oh.
No worries. What's the natural log of e cubed, Kelsey? Natural log of e cubed is 3. So Kelsey, what is 1 subtract 3?
Oh,
Positive. Ah, much better. The sign is the number doesn't really matter. The sign is really important. So this is negative, these are all negative. Much better, good. This is quite the flip. We good to hear? Okay, for all these different t values, just answer as a class, please. For all these different t values, is this factor t squared going to be positive, negative, or both? It's a little weak. Let's try it again.
Positive.
Positive!
Take it.
No. All right. Yeah, I'm just more subtle than Mr. Recti. So you're like, yeah, oh, class ticket. I'm like, everybody got it? 2 tickets for all. I actually do it quite regularly. What's that? I always give 2. If I call your name, you should be marking down 2. That's the rule. That is the house rule, right? Lindsay knows. Right. Thank you. That is the basic rule. If I call on you, you always write down 2. So. Cool. Beyond that is kind of based on your answer, whether I kind of give you more or whatever. I hardly ever give you less, but is everybody good? Awesome. So now we make the sign chart of B prime. Oh, something to be cautious about. Look up. Something to be cautious about. No. The 2 factors are not multiplying. They're dividing. So you have to be just a little extra careful. So 0 divided by a positive, that's easy. That's still a positive. That's still a 0. If it were the other way around, however, this would be a 9. Okay. Please, Mikhail.
So since 0 squared is 0, just changing the thought.
Good choice. Good question, I should say. Sorry. No, because we're only worried about values that are greater than 0. So we're actually not starting at 0.
Okay.
That makes sense?
Yeah.
Good call. This is positive. There's a positive divided by a positive is positive. This is negative. Okay. Please note, extremely important. Do not think I am drawing B prime. I'm not going to draw B. I'm not drawing B prime, I'm drawing B. Someone answer this question. Look at the chart. Something got mixed up on this last period. Look at the chart. This is, I need a helper. I need someone to talk with me. Okay, here we go, Braden. This is velocity equals 0, time equals 0, or both. Time equals 0. So Braden, from time equals 0 to what time is this? T. So from time equals 0 to roughly 2.7, so just think of it as seconds. So from time equals 0 to time equal 2.7 seconds, V prime is always positive. So during that time period, Braden, what will the graph of V be doing? Perfect, going up. 3 tickets for Braden. So let's label this point right here. This point has a t-value of what? Say it?
2.7.
2.7-ish, so let's say E. And the velocity value we don't know, so we'll say V of U. Is everyone clear on this idea? The reason I'm emphasizing, last period somebody got mixed up. They kept thinking this was time equals 0. Because they were looking here. This is V prime equals 0, not time equals 0. Very clear? After that, V goes down. Okay, it shouldn't be too hard to tell. Where is V going to be highest?
At E.
At E. Just write down the answer. Cool. Oh my gosh. Another question?
So for the sign chart, do you always draw the graph as you're trying to find the maximum profit, like whatever you're trying to find?
Great question. Great question. Here's the answer. This is what Kelsey said. This is really important. She's right. Most of the time when we're doing a sign chart of, say, like F prime or B prime or A prime, it's so we can get a picture of, look at the correspondence here. We're making a sign chart of F prime so we can get a picture of that. And we're making a sign chart of B prime so we can get a picture of B. Or a sign chart of A prime so we can get a picture of X. Exactly right. To be comfortable with this idea. Now the second thing you said is important to write down as well. Ever is kind of a tough word, but I would advise you not to do it. Don't draw a picture of F based on the sign chart of F double prime.
So what about if you were doing like concave up and concave down?
Very good. So I don't want a picture just because you really will probably make a mistake. You'll probably not do it correctly. You'll make a mistake. You'll interpret it incorrectly.
So just bag the picture altogether.
Just bag the picture and just look at the chart.
Okay.
Does that make sense?
Yeah.
So yeah, in fact, let's write that down. Hold on. So, come on, move, you dumb thing. There we go. Don't ever draw a picture of F based on F double prime sign chart. Instead, quote, bag the picture.
Okay.
And just interpret the F double prime sign chart. Does that make sense, Kelsey?
Yeah.
Yeah, that's perfect. Yes. Yeah, our rough picture right here, Sarah. This is our kind of our rough picture of what V looks like. So we had a sign chart of V prime. Making a quick, crude picture of V is pretty easy. So, yeah. Awesome. Next example. Turn to 13. I don't know the right answer. I just know.
Sorry, like
E, yeah, sorry, didn't understand that. Here we go. First thing, when is the function increasing? So think of Quadratic's chart. Stop right there, because that's far enough. I can tell that f is increasing if I can figure out when f prime is positive. So I need a sign chart of f prime. So I need a sign chart of f prime. Does anyone need clarification as to why I figured out very quickly that I need a sign chart of f prime? Two more for Sarah, because positive feedback is always appreciated.
I really like your handwriting.
You say really do or don't?
I do.
Don't give it.
I'm just giving you positive
Oh,
feedback.
thank you. 30 points for that.
No! Don't give it to him.
Here we go. So here's f. I need the derivative, so product rule. Please do not get lazy and start using bad notation. Two bad things will happen. One, if you ask me for help, I'll just hand you your homework right back and say, I can't do it. Like you have to talk mathematically. You can't hand me just a pile of junk and say, what did I do wrong? Like, I don't know. So you've got to speak mathematically. Second thing is, on a test, if you don't have good notation on the written portion, you're going to lose points. And on my test, if you don't have good notation, you'll make mistakes. So this derivative is just 2x. The derivative of e to the something is simply e to the something multiplied by the derivative of that something. Question. Did you catch up? Notes are still, pencils are still moving. Cool. So now we have f prime 2x e to the negative x. This is going to be -1. So -1, we can write it like this, just minus x squared minus 3 e to the negative x. Pause for anyone who needs help. Absolutely have to, because we can't make a sign chart of f prime unless we factor f prime as much as possible. So we identify, as Kelsey just said, e to the negative x is a factor of this expression, e to the negative x is a factor of that expression. Therefore, the next line will say,
Do you want to do that at also?
oh, thank you. You can't. Make see why. What are the factors of this expression, Ellie? Good, let's change colors here. So 2x e to the negative x. What are the factors of this expression? Much better. So x isn't a factor of that expression. X squared minus 3 is, but not x. Does that make sense?
Yeah.
Good. You know? Oh, please.
Does the negative 1 for the subtraction come from the pH negative x over dx?
Perfect. So this is equal to negative 1. When I write minus, it really is the same as saying negative 1 times.
How come we wouldn't write the x squared minus 3 e to the negative x minus 1?
Oh, nicely said. So, perfect, 3 tickets. Plus the 2 more you got for the other question. So this is x squared, here's what you said, Lindsay, it really is well done. So you have this, right? Then we have e to the negative x. Are these two things multiplying or subtracting or adding?
Multiply.
Those are multiplying. So this becomes negative 1, so you wouldn't write minus 1, that would be subtraction. But you can do this.
Okay, so here's the.
Right, so perfect. With multiplication, the order doesn't matter, so I just moved it over here.
Okay,
2 more, it's perfect. Yeah. Rock them up, man. So we pulled out the e to the negative x. That leaves a 2x minus this thing. Pause so you can catch up. Awesome. So now we go here. Oh, please.
Can you distribute the negative so it's adding that?
Yeah, we want to do that for sure. Because again, we don't want to start the sign chart until we can get as factored as possible. So distribute the negative. Then another problem is you have to have this in rapid recall memory. This is a quadratic. You don't want to make a sign chart with a quadratic, you'll get it wrong. You want to factor the quadratic. But negative x squared is not my best friend. So I'm going to factor a negative 1 from each of these terms, meaning the negative 1 will come out here. This will be negative now. This becomes positive. This goes back to negative. Now I just write it in a more familiar order. Let you catch up. Please, Chuck.
And then the parentheses is dropped because there's now only positive, like the positives on each side or whatever you said.
The parentheses here.
No, the
Oh, up
x
here.
squared minus 3.
Yeah, once we, basically it said we must minus, how do I say this? If this were plus, we wouldn't need the parentheses at all. Because a plus distributed doesn't change anything. If this were minus, and these two terms were being multiplied, we would not need the parentheses either, because there's no distribution. So because it's minus, and inside here are two things being added, we must distribute. Once we've distributed, we've taken care of what the parentheses were there for. Does that make sense?
Yeah.
Please don't.
So then it would just be e to the negative x times, x minus 3 to this 1.
Nicely done. Perfect. Now we're in a nice factored form for f prime. Oh, Chance, please.
Wouldn't the x minus 3 and the x plus 1 like technically need to be in another set of parentheses because the negative 1 e to the negative x goes to all of those things? Or would it not matter because of the more?
That's an outstanding question. 5 tickets. That's really good. I got to think for a second to answer it. It's a really good question. Hold on. So you're right. If we were to distribute this back through, it would have to go this times this, this times this, this times this. Absolutely. What we did, Chance, is we said this can be written as two things multiplied. So now instead of having 1, 2 things multiplied, we have 3. Well, with multiplication, you don't ever double multiply. Stay here for just a second. You don't say this times this and this times this. So we're okay. Like, separating it is fine. You don't need extra parentheses, because if you decided to distribute, you have 2 options now. You can multiply these 2 first, which gives you this.
Yeah.
Or you can distribute here, get a new thing, and then multiply those 2. That's a great question. I will finish this example in the video. I'll just
please come to the main office. Alex
and
Galloway,
so you can watch the conclusion online if you need to. From here, it's just a matter of making the sign chart. It's pretty straightforward. One big thing, listen close, hey.
and Cole Willis.
Look at
Please
this
come
one.
to the main
E to
office.
the negative x.
Again,
I've
if
said
I
this
could
before,
please
it's
have
reminding you.
Ali
This
Schoenberg,
is always
Sarah
positive,
Galloway,
regardless of
Kathy
x.
Kennedy,
So e to the power is always positive. So this factor right here is going to be positive for all x.
Shayna
Multiplied by the negative
Mumford,
1 is going to make
and Cole
this
Willis.
equal negative
Please
for
come
all
to the
x.
main office.
So if you're not sure, check the notes, look at the video, I'll say it again. Yeah, I posted my. So here's an example. E to the negative x. Let's just make a quick table. Yeah, the reason it becomes positive is simpler than that. Like you choose some value for x, I don't care. 36. That will put x right there. You're okay, hold on a second. So this should say x, this would say 36. So this would be e to the negative 36 power. But that's the same thing as 1 divided by e to the 36.
Oh, so it's even though it's really small.
There you go.
Okay.
Does that answer your question? Good job.
The homework's in the blueprint, right?
Yeah, I'll text it out here in a minute. So. Good question.
How would you read it?
2. So basically, go here, now we just make the cycle chart. So because e to the something is always positive, and 1 makes it always negative. Cool. I'm talking to myself.
Oh.
Just wanted to finish the recording. You can go whenever you're ready.
Okay.
Thank you, Deborah. Thank you.
Bye.
One second, Jim. So we finish this off. So x is equal to -1. This would be 0. Therefore, the sign chart for f prime is going to be 0 here, 0 here, negative here, positive here, negative here. So now I can simply write down the answer. F of x is increasing for -1 all the way to